Mars is the one planet that keeps haunting us. It's not too hot, it's not too cold. It has seasons, it has ice, and long ago it may have had rivers. So the question feels obvious. If humans went to the moon more than 50 years ago, why are we still stuck talking about Mars instead of standing on it? The uncomfortable answer is this. Going to Mars is not the next step after the moon. It is an entirely different category of problem. And today, we're going to break down exactly why. Not with sci-fi fantasies, not with political promises, but with physics, biology, and cold logistics. The moon tricked us, and that's the problem. The moon gave humanity false confidence. It's close enough that brute force works. 3 days of travel, a short stay, and a quick return. Even during Apollo, astronauts were never truly far from home. If something went wrong, Earth was only hours away. Mars doesn't allow that luxury. Mars forces you to leave Earth behind in a very real way. Low Earth orbit is not space in the way you think. Astronauts on the International Space Station feel far away, but they're not. Their orbit just a few hundred kilometers above Earth. That's about the distance between major cities. They're still wrapped in Earth's gravity, still protected by Earth's magnetic field, still one emergency launch away from rescue. Mars missions leave all of that behind. Once you burn out of Earth orbit, there is no rescue plan. There is no turning back easily. You're committed. Mars is not far, it's moving. People talk about Mars like it's a fixed destination. It isn't. Earth and Mars are both racing around the sun on different tracks. Sometimes they're relatively close, sometimes they're on opposite sides of the solar system. The best alignment happens roughly once every 26 months. Miss that window and you wait more than 2 years. That alone dictates mission schedules, budgets, and lives. You don't fly to Mars, you change orbits. Here's the part most people never realize. Space travel isn't about speed, it's about energy. To reach Mars, a spacecraft must escape Earth's gravity, enter a solar orbit, reshape that orbit to intersect Mars, arrive at the correct time, and slow down enough to not miss the planet entirely. Every one of those steps costs energy, and energy means mass, and mass means fuel, and fuel makes everything heavier. The distance problem turns into a time problem. A typical Mars journey using efficient trajectories takes about 6 to 9 months. That doesn't sound terrible until you realize what those months mean. 6 to 9 months exposed to cosmic radiation, 6 to 9 months in microgravity, 6 to 9 months in a confined metal shell. And that's just one direction. Mars missions aren't round trips in the normal sense. You don't land, explore, and immediately return. The planets won't allow it. To return efficiently, astronauts must wait on Mars for the next favorable alignment. That means staying on the surface for more than a year. So a typical mission looks like this. Travel to Mars, stay on Mars for over 500 days, travel back to Earth. Total mission time, around 2.5 to 3 years. That's not a visit, that's an exile. Apollo missions lasted days, Mars missions last years. That difference explodes everything. Food, water, oxygen, medical supplies, spare parts. You can't resupply a Mars crew. Everything must be carried from Earth. And every kilogram adds fuel requirements, which adds more kilograms, which adds more fuel. It's a brutal spiral. Radiation is the silent killer. Earth protects us. Its magnetic field deflects charged particles. Its atmosphere absorbs radiation. Between Earth and Mars, that shield is gone. Astronauts would be exposed to solar particle events, galactic cosmic rays, long-term DNA damage. This isn't a theoretical concern. We already know radiation increases cancer risk and degrades the nervous system, and shielding against it adds mass. There's no easy solution yet. Microgravity breaks the human body. Months in microgravity weaken bones, muscles shrink, vision changes, the immune system degrades. Astronauts returning from 6 months on the ISS need help walking. Now imagine asking that body to land on Mars, put on a suit, and operate in partial gravity immediately. We don't know if the human body can adapt fast enough, and we don't yet have rotating spacecraft that simulate gravity at scale. Psychology is not optional. Mars missions break the human mind in new ways. No real-time communication. Messages take minutes each way. No emergencies resolved quickly. You're alone, with the same few people, for years, in a hostile environment where one mistake can kill everyone. That kind of stress has never been tested at that scale. Fuel is the final boss. To go to Mars, land, survive, and return, you need enormous amounts of propellant, hundreds of tons, which means multiple heavy launches, orbital assembly, perfect coordination, no major failures. Even with modern rockets, this is a logistical nightmare, and that's assuming everything works the first time. Impossible doesn't mean never. So is it impossible to reach Mars with today's technology? For routine, safe, repeatable human missions? Yes, effectively. Not because we lack courage, not because we lack ambition, but because physics doesn't negotiate. Mars demands new propulsion systems, better radiation protection, artificial gravity solutions, reliable in-situ fuel production, and a level of redundancy humanity has never built before. We're not there yet. The real question is not, can we? The real question is, are we willing to build the civilization required to go? Mars is not a destination, it's a test of patience, of engineering discipline, of long-term thinking, and of whether humanity can survive years away from its cradle. So, here's my question to you. Do you think humans will reach Mars in your lifetime? Or do you think Mars will remain a robotic world, explored by machines but never walked by humans? And if we do go, should it be a one-way settlement or a mission that comes home? Drop your answer in the comments. One opinion, one reason. And if you want to explore what humanity might become, beyond Earth, beyond tomorrow, beyond 2200, subscribe.